Welcome to 4-2 Powers and Exponents. We have two objectives today. One is to write expressions using exponents. Our second is to evaluate expressions containing exponents. Right before we begin, we got three things that we want to define here: is the base, exponents, and power. Right now we're going to use this example. Sometimes it's read as 2 to the fourth power, or 2 raised to the fourth power is another way. There are parts to this, and the first one we're going to talk about is the 2. The 2 is the base. It is the number that is multiplied. Then, in conjunction, we have this smaller fourth. This is not 24, but this is 2 to the fourth power. This 4 is called the exponent. It tells how many times the base is used as a factor. In the last lesson, we kind of went over factors. It means to multiply. Now, all together, as you can see here, 2 to the fourth power, the number that can be expressed using exponents is called a power. Alright, so this whole thing here is called a power. The base is the number 2, and the exponent is the 4. And this tells us that this is a shorthand for saying 2 times 2 times 2 times 2. Alright, so we decided to write it a little bit shorter, 2 to the fourth power. Alright. If you're unfamiliar with powers, exponents, and bases, we have a chart here to get you used to it. We're going to use 2 as our base, and the first one is 2 raised to the first power, and that's how we would say it. And in the third column shows us what it would look like if we were to expand it. Since there's only one 2, it's just 2. Then we go to our next one, 2 to the second power, or 2 squared. So what does that mean? That means if we were to extend it out as a factor, it would be 2 times 2, because 2 is our base, and we have 2 of those bases multiplied together. Our next one is 2 to the third power, or 2 cubed. That's how we would say it. And basically it says, take our base 2, write it down 3 times, and multiply those together, and that'll give us our answer. And then, like on the last page, 2 to the fourth power, or 2 to the fourth. And that means, of course, take our base, write it down 4 times, and multiply them all together. We can do that to infinity. That's what that means. When a number is raised to the first power, the exponent is usually omitted. So 2 to the first power is written just 2. It's just one of those things we acknowledge. Like there's always a number 1 in front of a variable. We just omit it because it's already known. In this slide, we continue on with our parts of our exponents and our powers. Like before, 2 to the first power, we omit the 1. Well, here's another concept that you should be familiar with, is that any base, except for 0, raised to 0 is 1. So we have several examples here of 1, 2, 3, 4, and 5. So please remember that 0 power, alright, means that the answer is automatically 1. Let's continue on some of the extra information about exponents. An exponent goes with the number, variable, or quantity in parentheses immediately preceding it. So in our first example, this 3 squared goes with the 3, not the 5. So that explains why, if we were to write it out, it would look like this. The power of 2 goes with the 3. Now let's look at our second example, where the quantity of 5 times 3 is raised to the second power. Just want you to know that, remember, it's the base, okay, and this 2 tells us that we need to take the base twice and multiply them together. And that explains why this is the proper way to write this answer. And then another common misconception is the quantity of negative 9 raised to the second power is not the same as negative 9 squared. Alright, so what we need to know is that it's basically taking the base 9 and squaring it, then multiplying it by a negative 1. That's what happens without a parenthesis. With a parenthesis, it's the base twice. And that's something that we'll work on in the future. Alright, write each expression using exponents. So what we learned in the previous slides is that we have 3 being multiplied together several times. So that tells me that the base is 3. The number of times 3 shows up, 1, 2, 3, 4, 5, gives me the exponent. Alright, so base is 3, exponent is 5. So our power here is 3 to the 5th. Let's try that again with the next one. This time it's a variable. I notice that the variable is being multiplied together repeatedly. So I'm going to take the variable that's repeating, t, count how many t's we have, 1, 2, 3, 4, and that gives me my exponent. So t is my base, 4 is my exponent, and the power is t to the 4th. Directions are the same on this slide. Write each expression using exponents. The first problem I see here is parentheses, -9 times parentheses, -9. Alright, so when I want to write this with exponents, I want to make sure that I copy the base exactly the way it is. It's just not -9, it's actually parentheses, -9, and parentheses. There's 2 of them. That explains what my exponent is. So the base is parentheses, -9. The exponent is 2, and the power is the quantity of -9 raised to the second power. Alright, so let's be careful here on the next one. We have the quantity of x plus 1 times the quantity of x plus 1 times the quantity of x plus 1. Now let's find out what our base is. Our base is the one that is repeating. Once again, we must include everything that's repeating. So the parentheses come along with us. There's our base, exactly the way it is. I have 3 of them, so that's my exponent. So my power is the quantity of x plus 1 raised to the 3rd power. On this slide, the directions are the same. Write each expression using exponents. Now we see a varied. We see 7s, we see A's, we see B's. What we know is that all of these will be our base. We just need to write it correctly. I see my first base is 7, and there's only one of them. I could put a exponent of 1, but we usually omit it, like I said earlier in the lesson. I notice that my A repeats, so that's my base, and it repeats 3 times. Then I see another base, B, so I'll write that down, and that repeats twice. So what we have here is that we've taken the expression and we used exponents. We have 7 times a cubed times b squared. And remember, when we have variables next to each other and numbers next to variables, that means to multiply. Right, this is a good time to review. Order of operations are sometimes known as PEMDAS. And we see our example here. The quantity of 3 plus 4 raised to the second power plus 5 times 2. The first thing we want to do, of course, in PEMDAS, or order of operations, is deal with everything inside the parentheses. So 3 plus 4 is 7. Now we go to the next part, E. E means to evaluate all the powers, or the exponents. So 7 squared is 49. Then, depending on its location, from left to right, we'll either do multiplication or division first. So that's where we get the 10 from. And the last thing to do is adding or subtracting. Doesn't matter who goes first, long as we follow the order of left to right, like we did in multiplication. The answer is 59. All right, now that we've reviewed order of operations, or PEMDAS, let's evaluate each expression. So what does 2 to the 3rd power actually mean? Well, we can take this, what we call like a shorthand here, and we can use factors, or multiplication, to expand it so we can visibly see that this means 2 times 2 times 2, which in a calculator, our mental math, is 8. So there you go, ladies and gentlemen, evaluating an expression, 2 to the 3rd power, r2 cubed. Alright, using the same directions, we're going to evaluate each expression. This time this expression has a variable y, and we've been told what y is equal to. Right here it is a -3. Whenever we're substituting with exponents, we want to make sure that what we substitute is put into a parenthesis. So that would be negative 3 and then raised to the second power plus 5. What this does is that it says take negative 3 times a negative 3, and 2 negatives make a positive. That would be 9 plus 5. And let's just finish this up. That is 14. And let's do just a review. What would happen if there was no parenthesis there? What would my calculator give us? Or what would be the proper way to write this? And here we go. Without the parenthesis. Basically what this means is negative 1 times 3 squared. And we know from our previous example 3 squared is 9. And is negative 9. So it's important here when we are plugging and chugging to whenever we're substituting, whatever we're substituting with, whatever number, put it in parentheses. Let's continue on evaluating each expression. This time we have more than one variable to substitute our plug and chug. X is equal to a negative 2 and y is equal to 1. So 3, here's where I plug and chug. 3 times the quantity of negative 2 plus 1 raised to the 4th power. PEMDAS says do everything inside the parentheses, so I get a negative 1 raised to the 4th power times 3. A quick little shortcut here is that, of course, if you have an even exponent like 4 is, that just tells me the negative inside changes to a positive, and 1 to the 4th power is 1. We still keep the parenthesis because the 3 is on the outside, and our final result is 3.